Welcome to Tech Blueprint, a window that lets you know the latest technology news in the world. Engineers at SMIC are debugging the world's first three-dimensional stacked chip production line. The 14-nanometer process chips have achieved the equivalent performance of 3 nanometers through three-dimensional packaging technology. This scene is very similar to the historical moment when BOE broke through the blockade of LCD panels 20 years ago. When the U.S. Department of Commerce included the 37th batch of Chinese companies in the Entity List, they may not have expected that this carefully woven technical iron net was being torn open by Chinese engineers using innovative three-dimensional packaging technology. The U.S. technology blockade began with the complete supply cut to Huawei in 2019, and more than 1,200 Chinese technology companies were included in the Entity List in the following 3 years. The CHIPS Act, launched by the Biden administration, has invested $39 billion in domestic chip manufacturing, trying to drag down China's semiconductor industry through a subsidy war. But history always repeats similar scripts. Just as the withdrawal of Soviet experts in the last century gave birth to the 2 bombs and 1 satellite project, the extreme pressure from the United States has activated the innovation gene of China's chip industry. Data shows that in 2023, China's semiconductor equipment sales surpassed South Korea for the first time, and the global market share of 28-nanometer mature process chips soared from 3% to 29%. This seemingly impossible breakthrough is subverting the rules of the game in the global semiconductor industry. When TSMC and Samsung invested $100 billion in the competition for 1-nanometer process, Chinese engineers chose to find another way. Shanghai Microelectronics' 28-nanometer lithography machine has achieved mass production of 14-nanometer chips through multiple exposure technology, and the yield rate has stabilized at more than 92%. What really rewrote the rules of the industry was the three-dimensional packaging revolution, led by SMIC, stacking 10 layers of 14-nanometer chips vertically, and shortening the signal transmission distance by 80% through silicon via technology, TSV. While the performance is equal to that of 5-nanometer chips, the cost is only 40% of the latter. This innovation is like building the Eiffel Tower with Lego bricks. It not only overcomes the problem of thermodynamic distribution, but also solves the compatibility problem of chips of different materials. The breakthrough in the field of memory chips is equally amazing. Yangtze Memory's 232-layer 3D NAND flash memory technology increases storage density by 40% through the innovative X-stacking architecture, while the cost is 17% lower than Samsung's similar products. The yield rate of Hefei Changxin's DRAM chips jumped from 60% to 90% in 3 months, directly leading to a 30% plunge in global memory chip prices in 2024. Behind these technological breakthroughs is the full process, tool chain autonomy of Huawei's EDA software, and the support of SMIC's 5-nanometer etching machine entering the international supply chain. In the battlefield of chip design architecture, Chinese companies staged a textbook lane-changing overtaking. When AIM stopped supplying the V9 instruction set, Lungsen Juncker independently developed the long arch architecture through reverse engineering, and its performance was 90% higher than the previous generation. And Alibaba's Pingqiuji's chip shipments, based on the RISC-V architecture, exceeded 3 billion, allowing smart door lock manufacturers to obtain face recognition capabilities at a cost of 30 cents. This democratization of computing power directly rewrote the market structure of IoT chips. The deep driving force of this technological revolution comes from the coordinated breakthrough of China's semiconductor industry chain. A technical alliance composed of 12 core equipment companies including Shanghai Microelectronics, China Micro Semiconductor, and North Huachuang has shortened the equipment verification cycle from 24 months to 12 months. In the field of materials, the $140 billion investment in the silicon carbide industry has laid a solid foundation, and the localization rate of photoresist has increased from 5% to 35%. Even OFILM, which was once kicked out of the Apple chain, has achieved a positive net profit with the help of Huawei's orders, and staged a comeback against the wind. The counterattack on the market side is even more fierce. In the first quarter of 2024, China's chip imports fell sharply by 350 billion yuan, and most of these orders went to local companies such as SMIC and Huahong Semiconductor. BYD has increased the yield of automotive-grade chips from 47% to 98% through large-scale trial and error, with an annual output of 3 million IGBT chips, directly promoting the full localization of electric control chips for new energy vehicles. What shocked the West even more was that Tesla urgently went to China to discuss cooperation, hoping to use mature processed chips made in China. This scene is very similar to the history of high-speed rail technology surpassing Siemens 10 years ago. The rise of China's chip industry is triggering a chain reaction. Texas Instruments' industrial chip profits plummeted by 52%, and the CEO bluntly said that Chinese opponents used our retired technology to grab the market. ST Microelectronics reached a 28-nanometer foundry agreement with Huawei, breaking the Western fantasy of desinicization. Africa's first smartphone production line landed in Ethiopia, and mobile phones equipped with Unisoc chips are priced at only $35. This disruptive innovation has caused ASML CEO to warn, it is meaningless to prevent others from producing what they need when the manufacturing cost of China's 28-nanometer chips is only 60% of TSMC. Any technical barriers seem pale and powerless. The most profound revelation of this breakout battle is that it redefines the path of scientific and technological innovation. The photonic clock chip developed by the Peking University team increases the time control speed by 100 times, and a single chip can support the communication upgrade from 5G to 6G. The quantum detector developed by the Chinese Academy of Sciences can accurately remove defective chips and cooperate with graphene heat dissipation film to solve the heat dissipation problem of three-dimensional stacking. These underlying innovations are building a new technology ecosystem. From rewriting the performance definition of three-dimensional packaging to opening up a new track for the RISC-V architecture, from the cost revolution of mature processors to the frontier exploration of photonic chips, this long march of science and technology proves that true innovation never catches up on the track set by others, but opens up new dimensions through system engineering innovation. When 60% of traditional chips of American automakers rely on Chinese manufacturing, and when 62% of electronic products in the world use Chinese chips, this industry, which was once asserted to be at least 10 years behind, has become a key force in reshaping the semiconductor order.